Now it's Ilpo with PCIe bandwidth controller. Thank you, Ilpo.
Yeah, so we continue with the port driver related stuff now. So I'm going to talk about this PCIe bandwidth controller. So what is the bandwidth controller? So it basically is built to control or throttle the PCIe link speeds. So this is primarily done for thermal or power reasons, but there could be other reasons beyond that. And it adds an internal API to change the link speed. And for user space control, there is this paired thermal cooling device, which can be used by the thermal D or some other user space applications. And when the PCIe 6 comes, also the link speed might be eventually controllable. So this is not something the current patch adds, but it might be possible in the future. So the link speed management in PCIe, it consists few bits in the register. So we have this link bandwidth management status, LBMS, and then also this autonomous status. They are asserted when the link speed or width is changed. And then we have the associated interrupt, which can be enabled. So this binds this driver to the port driver. So because we are using the interrupt, it needs to be underneath the port driver. So it's a service driver. And this interrupt and the bit allows keeping the current link speed in the PCI bus structure up to date, and it's something that is actually not done currently, because there used to be this bandwidth notifications driver, but it got reverted. So currently this speed is only read when operating system asks for it, but of course the hardware could change the speed on its own, and we don't currently capture this speed change. And then there is this supported link speed vector in link couple is 2 register and target link speed in link control. And of course, there is also the current link speed in status register and things like that. And so the bandwidth control, or the link with control procedures as shown on this slide. So first we calculate the intersection of the supported speed. So we have the root port and then the endpoint underneath it, and they both have these link speed vectors, and we calculate the intersection of them, and then when we have the asked or the desired speed, we take the highest speed out of those. And this algorithm is currently written such that it also is able to handle these gaps in the link speed. So the spec currently requires that there are no gaps, but it also has an implementation note which tells that it might be allowed in the future. So this is kind of future-proofed. And once we have the speed, we adjust the target link speed register and then ask for the link to retrain and see what is the result. And this has certain integration challenges. So the LBMS bit is already used in the kernel. It's used for this one quirk, which I call target speed quirk. So I will come back to this on the later slide, and then also because we are adding this new API to change the target speed or the link speed, whether the bandwidth controller can anymore be disabled at all if some device depends on that. But I will also talk more about that on the upcoming slides. And then the third thing is, which is kind of heads up thing. So I have solved this. So there is this these bits in the link control and link control through registers, and there are different drivers which alter different bits there. So we need to do this safely so that we don't lose any of the bits. So if you are changing any of bits in these registers, please use the set and clear capability accessors so that you get the proper locking and no updates are lost. So what is target speed quirk is I mentioned earlier. So there are devices which fail to bring up the link at maximum speed. And this quirk was added to deal with such devices. So it's identified using the LBMS bit and the fact that the link did not come up. So it set this one bit but not the other. Then we try this quirk, and it goes to lower the link speed first to see if the link then comes up, and at least for some devices this works and they come up, and then there are also devices which once they have gotten the link up for the lower speed, they can then bring it up on the higher speed too. And because this quirk is changing the link speed, so it should use the new API, obviously. And the challenges include this monopolization of LBMS bit. So the quirk on one time it can run very early into the boot up process or the discover process, and at that point of time there is no PCI bus yet, there is no port driver or these service drivers yet at that point of time, but it can also be run at a later down. So this bandwidth controller code now needs to deal both of these cases, which is kind of annoying and adds a bit of complexity. And the quirk is usually on, so it can only be disabled if one toggles it or toggles the expert thing on. So it's kind of assumed to be there. And I made this table about the current approaches. So there are various cases to consider. So there's first of all the PCIe quirks and then the PCIe bandwidth controller. So when both are off, then of course there's not much to do. But when we have the quirks enabled, then the LBMS is handled directly. So without much from the bandwidth controller side, because it's mostly disabled. But there is little code to bridge this gap that the bandwidth controller is there. And then the cases when both are on, even that has this complexity. So during the initial scan we don't have the bandwidth controller up yet, so we need to do again this LBMS bit directly and not counting, and later in the later phases the LBMS is counted, and there are also some variations in the locking. So this it would be possible to simplify this if PCIe bandwidth controller is also hidden behind the expert config, so that you have to enable it. So then I would say that I just don't support certain things, but if somebody goes to disable it, so it would simplify. But still the last two rows are something that the current port driver timeline does not allow to get rid of. So from the point of view of bandwidth control, it would be nice if the port driver could kind of bring this thing up earlier, or something else from the PCIe core. And this brings me to the Kconfig integration. So because we have this internal API for changing link speed, so do the users require it always to be available? So I can imagine that there, and I think some of the cases in the kernel kind of which are currently changing the link speed kind of seem to indicate that this would be done because the device does not, for some reason, want to operate on a higher speed because it isn't reliable or doesn't really work. So it would kind of indicate that you always need this API to change the link speed even if the bandwidth controller would be disabled. So this is kind of the question then, whether it's useful at all to allow disabling it if there are things which depend on it.
So my view is that the idea or the motivation for the bandwidth controller is that we want to be able to throttle the bandwidth on PCIe devices if the case of a laptop becomes too hot, or if to just reduce power consumption, and if I think that is a common enough feature that we don't want to hide it behind the expert option. So I think it shouldn't be hidden, and well, we have to make it work somehow with that quirk. That's just my 2 cents.
I'm not sure exactly which way you said that.
So don't hide it behind the expert option. So
I mean hiding the disabling it behind the expert. So
another use case here might be just throttling the device in general. So VFIO introduced migration, and we might want to slow down devices so they dirty pages less quickly. I don't know if devices can do that transparently, but so there might be a non-thermal use case for this as well.
Yeah, I know there might be other use cases, but
Okay, 5 minutes.
A question, why do we want to hide bandwidth controller at all?
I meant that if it's not so easy to disable it, so then we don't need to solve all the complexity, because
why do we want to be able to disable it? Like, what's the reason? Why do you want it to be possible to disable it?
Well, I kind of expected that somebody would want to disable it, but
if there is no reason, then I wouldn't worry. If somebody comes up with a reason, then yeah, but till now.
Yeah.
Any other questions from the audience?
Yeah, I don't have anything else. So.
Anyone else having comments? You're good. Thank you, Ilpo.